Okay, today we are going to find the intersection of these two equations algebraically. So remember, the intersection is where they cross each other. So it looks like here we have one that's a quadratic and one that's linear. Since they both equal y, we can use equal values to set them equal to each other. So I am going to say that x squared minus 3x minus 10 equals negative 2x plus 2. And I'm going to write that out into a separate equation that we'll then solve. So x squared minus 3x minus 10 equals negative 2x plus 2. Okay, so this equation that I have now is a quadratic, and anytime I want to solve a quadratic equation, I need to make it equal to 0. So that means that I need to take this stuff and move it over to this side so that it equals 0. So I'm going to move the negative 2x by adding 2x to both sides, and since I'm adding a term that just has x in it, I need to add it to this term here, and I'm going to subtract 2 from both sides to get rid of this. And since I'm subtracting 2 and there's no x's, I'm going to subtract it from that. So these will cancel out and leave me with 0. Negative 10 minus 2 is a negative 12. Negative 3x plus 2x is a negative 1x. And nothing happened to my x squared, so that stays there. So now I have x squared minus x minus 12 equals 0. So I'm solving a quadratic. There's a couple different ways I can do it. I can do the quadratic formula. I can try to factor it, or I can complete the square. I am going to do factoring and see if that works. So I'll do my generic rectangle, my diamond. I put the x squared in the bottom left. I put the negative 12 in the top right. I multiply them to get my top, negative 12x squared, and the x term goes in the bottom, negative x. So since this multiplies to a negative, I know I've got a positive and a negative number, and they multiply to 12 and add to negative 1. So I'm looking for them. They're 1 apart. 3 and 4 are 1 apart that multiply to 12. I want the 4 to be negative, so I'm going to have negative 4x and a positive 3x. And then I put those over in my rectangle, and then I fill out the outside. So my factored form is now x minus 4 times x plus 3 equals 0. Now that's not solved yet. I still need to figure out what x equals. So I know that either this equals 0, so x minus 4 equals 0. That means x has to be 4, so there's one of my answers. Or this equals 0. So x plus 3 equals 0. That means x has to be negative 3. So there's my second answer. But I'm not totally done yet. I found my x's, but I need to figure out what y's go with them. So I can plug x back into either of my original equations up here. I can plug it into this equation or this one, because it should work for both of them. The points are on both of those graphs. I'm going to put it into y equals negative 2x plus 2 because that looks like a whole lot less work. So y equals negative 2x plus 2. First, I'm going to plug in 4 and see what the y value of that point is. Y equals negative 2 times 4 plus 2. That's negative 8 plus 2. So y equals negative 6. So my first ordered pair point of intersection is the point 4, negative 6. Now I'm going to do the same thing with negative 3. Y equals negative 2 times negative 3 plus 2. Negative 2 times negative 3 is a positive 6, plus 2 is 8. So that means my other point of intersection is the ordered pair negative 3, 8.